Hello and good day, geometry. We have come to the conclusion of algebra. Now that we're here, I can safely tell you you'll never use any of this again in your entire knowledge. But I saved the best for last in that not only do we get to solve an equation, but we get to solve an equation in its fullest potential. We are going all the way from one step, just addition or subtraction, past two-step, where you have multiplication and division, to now using exponents and radicals in our equations. Isn't that exciting? Okay. Now, the good news here is that all of you being PERMDAS people, you already know how to solve these. PEMDAS people, this is really tough for them because they look at that root in the equation. For example, let's just go straight down to that second one there. 3 times the root of x equals 27. Because we're solving an equation, we know we're using opposite operations here. We're going to start by dividing both sides of our equation by 3. Since we're multiplying 3 and root x together, to undo that, we're going to be dividing by 3. Right? Cancel out. That leaves us with the root of x equaling 9. 27 divided by 3. And PEMDAS people, they don't know what to do next. PERMDAS people, we know that if we're taking the square root of x and we want to undo that operation to get x by itself, what is the opposite of taking a square root? Oh, that went much better in my head. What is the opposite of taking a square root? How many times are you going to make me do that and look like an idiot until you square it, right? Exponents and radicals are opposite. Okay? They undo each other. So to undo the operation of squaring, of taking the square root, we are going to square. The root and the power cancel out. We're left with x by itself. And 9 squared equals 81. Okay? So, folks, you know how to do this already. You've done this math before. Now it's just doing it all together. I know everybody in here always checks their answers when they solve for a variable. When you solve a radical equation such as this, it is required that you do so. Because every once in a while, you're going to come across what's called an extraneous solution. Does anybody know what an extraneous solution is? Blake.
It sounds very painful and very annoying.
It's more so annoying than painful, I would say, because an extraneous solution is a solution for x that doesn't actually work. It's a solution for x that doesn't actually work in the equation. Yeah. Yeah. Basically meaning that when you solve for x and you plug it back into the equation, usually we can check our answer by plugging the value back in and the equation works, right? For an extraneous solution, it's not going to work. And it doesn't mean that you did anything wrong. It just means that math is sometimes quirky. Okay? And you're going to run into those extraneous solutions today. So we're going to take this 81 and we are going to plug it back into our equation and just make sure this works. Is 3 times the square root of 81 equal to 27? Since the root of 81 is 9, 3 times 9 is 27. This actually works out. It is not an extraneous solution. Okay? I saw a hand up somewhere, but I was on a roll, didn't want to stop myself. Anybody have anything to say? Mackie?
What's the point of it? Why do you even care about it?
About what?
The solution thing.
The extraneous solutions?
Yeah, why do we care?
Because if you're using this to like write a computer program for something, which like everything you do nowadays goes back to a program. If you've got a solution for your formula that doesn't actually work, now you got Facebook crashing for 12 hours and the whole world freaking out, right?
If we actually check our answers, like if we don't.
That's how you find them. If you don't check your answers and you put an extraneous solution as an answer on your test, I'm going to mark it wrong because that's not a solution to the equation.
So we have to solve it a different way,
No.
or you just get it right and you're fine.
Let's go over one that's extraneous and you'll see what I mean. Okay, Drake. When you solve an equation, you want to isolate whatever variable you have. Yeah, you want to get x by itself. Okay, so an example of one that's going to be extraneous. Let's look at the bottom middle one. Okay, the square root of x plus 7 equals x plus 5. And folks, I really need you to pay attention to this part here, because if there's a place, even though you've done all this math before, if there's a place that you're going to make a mistake, it'll be a question such as this. Okay, we've got variables on both sides, right? Our x on the left side is trapped under that root, which means we've got to release it first. We can't move this x over to the other side to be with the other x until we release it from that root. So what do we do first? How do we undo a root? PermDOS people. Peter? Square it. Okay? And here's where it gets a little bit tricky, right? Because you're squaring the left side to cancel out the root, leaving us with x plus 7. If you squared the left side, you also have to square the right side, which means you're squaring this whole thing, not just the 5, right? Not just the x, the whole thing x plus 5. So in your algebra brains, if you're thinking back to, where have I seen this before? PO 45. You knew I wouldn't close algebra without an old man foil or a crab claw for you to do, right? That just wouldn't be me, okay? When you're squaring this entire expression, remember, you can't distribute that power and put x squared plus 25, right? You're missing that middle term. That addition sign causes some problems there. So this is saying x plus 5 times x plus 5. You foil, you crab claw, what do you get? You do not get LeBron James. Close though. You're on the right track.
Let's go.
No, just pay no attention to that. Peter. Good. X squared plus 10x plus 25. If you simply distribute that exponent in, you miss that 10x term, right? But this comes from first terms, outside terms, inside terms, last terms. Hey, old man. You get x squared plus 10x plus 25. Mackie.
Never mind.
Okay. Yeah.
Could I be refreshed on why it's called old man foil?
Because it looks like an old man, kind of. It's got like the eyebrows, the first outside, inside last. It's the position of the terms in the parentheses. You have your first term in each parenthesis, your outside terms, your inside terms, and the last terms of each parenthesis. Okay. The box method? Oh, yeah. Hey, there you go. You can do that too. It is. Punnett squares. Yep. Anyway, now that we've got a quadratic equation, those of you that have been retaking your entrance exam stuff have probably had to retake something similar to this. We can't solve a quadratic equation until the equation equals what? 0. So we've got to move our x term over by subtracting it. And we have to move our 7 over by subtracting it, using opposite operations here. So on the left side, we now have 0 because both those things cancel out. And on the right side, we've got x squared. 10x minus x is positive 9x. And 25 minus 7 is positive 18. Mackie.
Why don't they, when we subtract the x from the left side, why don't we just subtract the x squared?
And move everything else over. So your options are either move our two terms from the left over to the right, like we did here, or move the x squared, the 10x, and the 25 over to the left. So it's moving two terms versus three terms. It's just more efficient to do it the way that we did here. You could do it that way if you wanted to, though. Okay. Blake, question?
Why do we subtract 1x from 10x instead of the x squared?
Because x squared and x aren't like terms. Now that we're combining terms here, x squared, it's the same variable but to a different power. It can't be combined with addition or subtraction, which is why we never combine the x squared plus 10x to get 11x squared anyway, right? We always kept these two terms separate because they're not like terms. They can't be combined. So when you're subtracting that x, you've got to subtract it from your x term. Okay? How do we solve this now? X squared plus 9x plus 18 equals 0. You've got two options. Last year, PO49 or PO59. Caleb?
The
Quadratic formula is one way. Okay, we don't like that. So what's the other way, Peter? Factoring, which means we're looking for those two sets of parentheses, right? The good news here is that because our coefficient to x squared is a 1, we don't have to do that 7-step process, right? The PO50 way, we have to take up the greatest common factor and do all that sort of stuff. In this case, we're only looking for factors of 18 that add or subtract to be 9. What are they? Factors of 18 that add or subtract to be 9. This is the easy factoring way. Drew? 6 and 3. So x plus 6, x plus 3. So, what are our two solutions for x? James? -3 and -6.
I remember that you have to make them negative.
Now, take the opposite. Or so we think. Okay? When we plug this back into the original equation, let's take our -6 first. The square root of -6 plus 7 equals -6 plus 5. Right? I'm taking that -6 and I'm plugging it in for x in my original equation. What is -6 plus 7? Those of you that wanted to go back to math 6, here's your chance. What's -6 plus 7? 1, right? What's -6 plus 5? -1. Does the square root of 1 equal -1? It does not. If you're about to say, well, wait a minute, though, I thought that every root had two answers, positive, negative thing. That's what we talked about last year. That's only in the context of parabolas. If you're ever asked for the root of a number outside of that finding the x-intercepts context, the negative answer isn't part of it. So the root of 1 is not -1, which means that this solution does not actually work, which means it is extraneous. -6 does not actually work. If we plug in -3, and I know I'm kind of going all over the place here, -3 plus 7, the root of that, equals -3 plus 5. This time we're plugging in -3 for x. -3 plus 7 is 4. The root of 4 is -3 plus 5. This one works. -6 does not. It doesn't mean you did any of the math wrong. It means that math is a little bit quirky. Okay? It's an extraneous solution. So if on a test you told me x equals -6 and -3, it would be wrong because x does not equal -6 and -3. It only equals -3. So for these, you do need to go back and check because you never know when an extraneous solution might just pop up.
So for every one of these, the ones where you have to put it in the quadratic formula or do factoring, will it always have one extraneous?
Not always. That's the best part, is that it will not always have an extraneous solution. Oftentimes, but not always. And you know me, what would I put on a test if I wanted to make sure you're checking answers? Mackie.
So, let's say you look at an equation. How do you know if it's going to be like that or not?
Yeah, Doc, I'm going to need to schedule an extra session this week. Yep. Okay. Yeah. Yep, it's him again. Okay, thank you. All right. Another one you'd like to do together.
The session is down.
Blake. Last one, second row. Ooh, geez, that looks horrendous. Okay. Yeah, it does. Well, we will tackle it. Let's go. So this one's got all three levels of PERMDAS to it. It's got addition or subtraction with that positive 8. It's got multiplication, division with that coefficient to the root. And it's obviously got an exponent root with the root there. Okay? So where do we start? What do we do first? Gino, you want back in? What do we do first? We would not. We wouldn't divide. You've got the right numbers. We wouldn't divide by 8. We'd subtract, right? Since we're adding 8 opposite operations, we're going to subtract 8 from both sides. You kind of work through PERMDAS backwards. You start with addition, subtraction, and move on that way. So now we've got negative 2 times the root of 3x minus 3, and that equals a negative 24. Okay? What next? And again, this cancels out here. That's why we subtracted 8. What do we do next? Drake? You can't distribute into a root. They're not like parentheses. Okay? The root is an operation where parentheses aren't. Okay? So you can't distribute in. Drake, this says negative 2 times the root of 3x minus 3. What's the opposite of multiplying by negative 2? Dividing. So that's what we're going to do next. We're going to divide both sides by negative 2. Because that's going to cancel out that coefficient in front, leaving us with the root 3x minus 3. And that equals a positive 12. Okay? Now that we've got the root by itself, we can't do anything with what's inside the root until we release them, right? They're kind of trapped under that root. So our next step is to square it. Okay? We're going to square it. Square both sides to cancel out that root, and that leaves us with 3x minus 3 equals 144. 12 squared, 144. Okay? Joe? Now we're going to add the 3. Okay? 3x equals 147. No quadratic equation for this one. Let's go. Caleb?
X equals 49.
Divide by 3 to get x by itself. X equals 49. Or does it? Let's plug it back. Don't boo. Let's plug it back in and check. Okay? Okay? You can put the whole thing in your calculator. The thing you've got to be careful of, though, is that plus 8 is not part of the root. So you know how your calculator gives you that opening parenthesis? And I told you last year, make sure you get in the habit of closing it. This is why. If you don't close your parentheses, then it's going to include the 8 as part of the root, which is going to throw you off. Okay, so close your parentheses. Essentially, we get negative 2. 3 times 49 is 147. Minus 3 is 144. Okay, negative 2 times 12 is negative 24. And negative 24 plus 8 does equal negative 16. It does check out.
Yay. Let's go.
Wouldn't it be sad to do all that work and have it not work? That would be, oh,
That'd be kind of evil.
it would be.
It's already evil.
Peter.
Is there a situation when both solutions can be extraneous?
There are equations that have no solution. We've talked about those before. You know, when you've got the same number of variables on both sides. So it is possible where neither solution is going to work. Because why not, right? Okay, we've got time for one more to go over together. What do you? Which one is going to be the grand finale? Our final algebra example. Who do I never hear from in here?
Oh,
Yeah, Nathan.
Sydney,
Nathan.
the very middle one. I'm going to go out on a limb here and say that's a good choice. That's a good choice. Okay? All right. What are we doing first? What are we doing first? Caleb.
We're first gonna take or you add the 3 to both sides. So
Ooh.
Oh, the doctor's right back.
Hold on. No. Okay. We aren't going to add 3 to both sides here because that's just going to bring more stuff over to where the root is. Remember that at some point here, we're going to have to square both sides. We can only really do that when the root's by itself. So kind of your first thought here is, how do I get the root by itself? So Caleb, instead of adding 3 to both sides, we would subtract 4. Okay? Subtract 4. And that leaves us with the root of x minus 1 equals x minus 7. Now that the root is by itself, we are going to, Mackie, square both sides. And when we square that right side, we're going to remember we're squaring the entire thing, x minus 7. And we're also going to remember that we can't distribute that power. We have to think about it as x minus 7 times x minus 7, which you can use the FOIL, you can use crab claw, you can box it. 3 methods to do this. Okay? Hopefully one of them makes good sense. But anyway, squaring both sides cancels that out. We're left with x minus 1. And on the right side, we've got x squared minus 14x plus 49. Watch those signs. Okay, x squared minus 14x plus 49. And we got that from either crab clawing, foiling, or boxing. Okay? We have our quadratic equation, which means we can't solve for x until it equals 0, till the equation equals 0. So like the last example, similar to this, we've got to subtract our x from both sides. Make sure you subtract it from the correct term on the right side, our x term. And in this case, we're adding 1 to both sides to cancel out that negative 1. And that's got to go with our constant. Okay? So now everything on the left side's gone. We opposite operation that to give us 0. Now on the right side, we've got x squared. 14x minus x is a negative 15x. And 49 plus 1 is a positive 50. Our options are either the quadratic formula or factoring. Quadratic formula did not have great reviews from the last time. Okay? And luckily, again, this does not have a coefficient in front of our x squared term. So it's kind of the factoring beta version, okay? To where here, I'll finish it up here. Hopefully you're able to write a little bit smaller than I have to make sure that you can all see it here. But we're looking for two numbers that multiply to make 50, and those same two numbers add or subtract for negative 15. Joe?
5 and 10. I don't know which negative or I just know it's 5 and 10.
Okay, well, to make a positive 50, either they both have to be positive or they both have to be negative, right? Because negative 5 times negative 10 is a positive 50, positive 5 times positive 10, both negative. And we know that because we have that negative 15x there. So, what are our values for x? X equals what and x equals what? Positive 10 and positive 5. Or does it? Or does it? Okay, let's start with our 5 here. The square root of 5 minus 1, just replacing that x variable. Is that equal to 5 minus 3? 5 minus 1 equals 4. So the root of 4 plus 4, does that equal 2? The root of 4 is 2. Does 2 plus 4 equal 2?
No.
So does x equal 5? No. 5 is an extraneous solution. Let's go to 10. The root of 10 minus 1 plus 4, does that equal 10 plus 3? Or sorry, 10 minus 3. 10 minus 1 is 9. 3 plus 4, does that equal 7? Yes, it does. So 10 is the solution. 5 is extraneous. Yeah, right? Yeah, math. Can you imagine doing this when you first walked in my room last year as 7th graders, wide-eyed, excited for middle school? We've come a long way, folks. We've come a long, long way. Okay? Your homework for tomorrow is to finish the page.
Hey, I got $5 right here. $5. No homework.
Hey, that's an
I'll do it for you
investment
later.
for the Schultz ASL.
I cannot accept bribes from students. That would be illegal, and I would never do that, as demonstrated by the audio recording of this non-trans.
I'll give you a
Put another zero on there, and then we can talk. No, a full handshake, a firm. Oh, well, that is tempting. I'll tell you what. Questions, comments, concerns, complaints, compliments, congratulations, or cash offerings? No. All right. That's how you math, folks. Goodbye, algebra.